All right, my friends, back here, part 2, question number 26. This graph is concave up on what interval? You definitely need to press pause and do it first. Check that black book we've been working on. All right, so it requires the second derivative. So the first derivative is 3x squared subtract 18x. And then the second derivative is 6x minus 18. Make it equal to 0 and solve it. There's one critical number that makes the second derivative 0. That critical number is 3. Now draw a number line. Plug in a number less than 3 into the second derivative, like 1 or 2 or 0, and the answer is negative. Plug in a number bigger than 3, and it is positive. So, on what interval is it concave up? And the answer is from 3 to infinity. It's concave up where the second derivative is positive. What's the limit as x approaches infinity of this? This is a right-hand behavior question. I need the power terms. So I want you to do this in 2 steps. So take the power term of each factor and multiply them together. So that's 2x. That's x. Now be careful here. 3x squared is actually 9x squared. And then the same thing with the denominator. X times x times x squared. Those are the power terms. So if I simplify this, I get 18 x to the 4th, and then I get x to the 4th. So when I divide it, I get my answer. A little crackle in there. Number 30. Give an equation of a line tangent. So I know that's x, that's y, and that's the slope. So x and y are 2 and 4. The slope is found by taking the derivative and then plugging in the x value. All right, I'm going to get over this. So that answers 8. So then we write the equation y equals 8 x minus 2 plus 4. All right. We got this. 31. Here you're given a position equation. What's the velocity? Well, it's the derivative of that. So that would be 6t squared minus 12. For what values is the particle moving to the left? Well, to understand that, we take the velocity equal to 0 and solve it. So I'm going to add 12. Divide by 6. And then when I square root, the answer is positive and negative root 2. Draw a number line. This is the velocity number line. It has negative root 2 and positive root 2. Pick a number smaller than negative root 2 and see what answer you get, if it's positive or negative. So like negative 30. That's going to give a positive answer. Plug in 0 and then plug in positive 30. And the question is, when is it moving left? And you can see that it's moving left from negative root 2 to positive root 2. Justification is the work you're showing with the number line and showing that the interval where it's moving left is right there. The graph at the right shows the velocity of an object moving horizontally from 0 to 9. When is the object's acceleration equal to 1? Well, acceleration's the derivative or the slope of velocity. So where is this slope 1? So up 1 over 1, up 1 over 1. Right here, the acceleration's 1 because in that interval, the slope is 1. So that is from 0 to 2. When is the object moving left? Well, it's moving left when it's negative. So that's from 7 to 9. When is it moving to the right? It's when it's positive, above. That's from 0 to 7. When is it resting? That's when the velocity is 0. So at 7, it's resting. What is the speed of the object at 9 seconds? So at 9 seconds, it's -2, and it's the absolute value of that. That's meters per second. And so the answer would be +2 meters per second. What is the acceleration at 5 seconds? So at 5 seconds, what's the slope of this line? Down 1 and to the right 1, the acceleration's -1 meters per second squared. All right, last page. Can you find the absolute extrema of this? This is a table of values question. And we start with what the end values are of the interval. Then we find the critical numbers of the first derivative that are in the interval. So that's 6x minus 6. So the only critical number here is +1. That is in the interval. And then find the y values that go with these x by plugging into the equation. So if I plug in 0, if I plug in 3, this is the one that's going to cause me 3 squared times 3, 27, 18 plus 1. So what's 29 take away 18? That's 11, right? And then if I plug in 1, I get -2. So the minimum is -2 and the maximum is 11. Number 34, given this function, can you find this information? So the domain comes from the function. So the only number x cannot be is 0. The x-intercept from the numerator, that's 2. The y-intercept, we have none, because when you plug in 0, it's undefined. The vertical asymptote, look at the bottom, it's not removable, it's x equals 0. The horizontal asymptote is the power terms. Because the bottom is more powerful, the horizontal asymptote is 0. Draw a first derivative number line. It's there. So look at the first derivative. What are the critical numbers? What makes it 0 on top? +3. And then what makes it 0 on the bottom is 0. Those are the numbers that are critical. Oh, those are my intervals. Plug in -1. A negative times a negative is positive. And the bottom's always going to be positive. Plug in +1. Again, it's positive over positive. Plug in 4, and it's a negative over a positive. So where is it increasing? And you can go all the way to 3, or you can write it twice, but -infinity to 3. Where is it decreasing is from 3 to infinity. Draw a secondary number line. That's the secondary. What's the critical number? What number here makes it 0? That's 4 and 0. Again, use the second derivative. Plug in -1. Plug in 1. So sorry, -1 actually ends up being a negative over a negative, which is positive. +1 becomes a negative over a positive. And then 5. So that's a positive over a positive. This is concave up from -infinity to 0. This is concave up also from 4 to infinity. It's concave down from 0 to 4. Where's the relative maximum? So go to the first degree here, first derivative. At 0 is an asymptote. So at 3 is our maximum. So when I plug 3 into here, I get 1 over 27. What's the minimum point? There is no minimum point. So it never goes from negative to positive. Point of inflection, that's here. Again, 0 is an asymptote, so it's not 0. 4 is the point of inflection. So the concavity changes. 4 take away 2, so that's -2 over 4 cubed, which is 64. If you would draw a little sketch of this, we have an x-intercept at 2. We have an asymptote at 0 and 0. we have a maximum at 3 and just a little bit above. And then we have a point of inflection at 4. Oh, that's 4 take away 2 is a positive value. That's why I was confused. 2 over 64. Believe it or not, 1 over 27 is bigger than 2 over 64. 2 over 64 is 1 over 32. So in other words, but this is a maximum. That's why it's got to be a little bit lower. So here's 4, just a little bit lower. And then put the pieces together. So the first part of the graph is increasing and concave up. So we have the end behavior. It's increasing concave up with the asymptote. The next part, again, is increasing concave up all the way to 4. So again, concave up to 4, and then after 4, it's the other concavity with that end behavior. And there's what the graph looks like. All right, last one. The sum of two non-negative numbers is 20. I got it. The first two numbers, find the two numbers so that the sum of twice the first plus the square of the second is a minimum. So I have too many variables here. So I'm going to solve for one of them. It's actually easier to work with x. So I want to know what x equals. And then where there's an x, I'm going to plug in 20 minus y. I'm going to distribute. And then to find that minimum, I'm going to take the derivative. So that's negative 2 plus 2y. Make it equal to 0 and solve it. So I'm going to add 2 and divide by 2. So I have 1. These are two non-negative numbers, so that the numbers have to be between 0 and 20. So if I pick a number like 1/2 into here, 1/2 gives me a negative answer. If I put like 5 or 10 or 18 or whatever, it's a positive value. This is a minimum, so I know that. So when y is equal to 1, it's a minimum. And then what would x equal? What's 20 take away 1? And when y is 1 and x is 19, or the first number is 19 and the second number is 1, that creates a minimum value. All right, Mr. G Math over and out. Great job studying. Maybe do it more than once. Don't forget your black book, calculator, all that good stuff. I believe in you. And anyways, you're going to do great. Bye.